Okay, guys, we are going to start the unit on stoichiometry, and this is a weird sounding word in chemistry, but basically what it's going to allow us to do is basically real chemistry that a chemist would do in a company, and it's going to allow us to be able to figure out how much stuff we need to react to make a certain amount of product that we want. Okay, so that's the gist of it. So let's talk about the real life application of balanced equations. Okay, so a balanced chemical equation can help out in manufacturing by predicting the amount of reactants that you need and the amount of products that you can produce. Pretty simple. So equations are equivalent to a recipe. So a balanced equation tells you the ratios of the reactants that you need to react and the ratios of the products that you make. So if I know how much I have of one of the reactants, I can predict how much each of the products I can make. I can also predict how much of the other reactant that I need to get. Also, if I know how much of one of the products I want to make, I can predict how much of each of the reactants that I need to get, and I can also predict how much of the other product I will produce. We usually express quantity in mass or volume. We can also express quantity in moles, though, remember, from a couple chapters ago. That's going to be really important here. So these calculations of quantities in chemical reactions is called stoichiometry. So we're going to use an analogy of a cookie recipe. Okay, so the reactants are like the ingredients and the products are like the cookies that you make. So in order to make twice as many cookies as your original recipe, all you have to do is double your ingredients, right? And if you want to make half as many cookies as the recipe says, then all you have to do is divide all your ingredients by 2. So this concept isn't really all that hard. It just takes a little bit of thinking. Okay, we are going to talk about this another way. So let's say we have a tricycle company, and in an 8-hour workday, Tiny Tyke is scheduled to make 75 tricycles. Well, how many wheels would be needed to make these tricycles? Well, how could you figure it out? Well, some of you will be able to do it in your head. But how you could do it, you could say I need 75 tricycles. And for every one tricycle, I need 3 wheels. Right? So 75 times 3 would be 225. I need 225 wheels. Well, how many pedals would you need? Well, for 75 tricycles, for every one tricycle, it requires 2 pedals, right? So 75 times 2 is 150 pedals. And where are we getting these numbers from? It's like a formula, right? It's like an equation. I just know it. So what if there was a malfunction and in the wheel assembly line and only 200 wheels were salvageable? So how many complete tricycles could be made? How could we figure that out? Well, this is how many wheels we have. And it takes 3 wheels to make 1 tricycle. So 200 divided by 3 is, we can make 66 tricycles. Now what do you do with the leftovers? Well, I don't know. You'll have 2 wheels left over, but I can't make a tricycle with it. You'll have to make a bike, like a regular 2-wheel bike. Okay. So we're going to do some chemistry now with this, okay? So, the following shows the relationship between a balanced chemical equation and the quantity, the amount of reactants and products, and how mass is conserved. So we have a word equation here. We're going to write that as a balanced equation first, okay? So we have iron. So iron is Fe plus oxygen. Oxygen is O2 because it's diatomic. Iron 3 oxide. Iron's charge is 3, oxygen's charge is 2. Switch the charges. So there's the bare bones equation, and then we have to balance it. So I'm going to put a 2 here and a 3 here for the oxygens, and then a 4 for the irons. Okay. So let's go over what a balanced equation tells us. The first thing it tells us is the number of atoms or molecules or formula units, whatever we're talking about. It tells us how many there are. So I have 4 iron atoms reacting with 3 oxygen molecules. There's molecules because there's 2 of them. And that's going to make 2 iron 3 oxide molecules. Okay, the balanced chemical equation is also going to tell us the number of moles. And why is it the same? Because remember, the number of moles actually counts atoms. So that's why it's the same. So we have 4 moles of iron reacts with 3 moles of oxygen to make 2 moles of iron 3 oxide. Mass. Well, for mass, I'll have to look that up. I don't have that in my head. So the mass of iron is 55.845. Oxygen is, let's see, 15.99. And how many of them are there? Let's see. How many oxygens do we have? We have 3 molecules or 6 atoms. So I'm going to multiply by 6. So that is 95.94 oxygens. Okay. On this side, I have 2 irons. This is the charge of iron. Plus I have 3 oxygens. 15.999 times 3. So that's the mass of one of these. And then I need to multiply by 2. And I'm just now noticing something that I messed up on. This is the mass of iron, but it's only the mass of 1 iron, so oopsie. I'm going to multiply that by 4. Sorry, guys. It doesn't really matter how long you do this, you still mess up sometimes. Okay. So we're doing this to show conservation of mass. So the total mass of the reactants would be all the stuff on the left side. So we have 223.38 plus 95.94. So that's 319.374. And then there's only one product, so this is the total mass of the products. And as you can see, they're the same. So that's a good thing. That means I did all my stuff right, and it should always be the same because mass has to be conserved. Okay? So you're going to do some practice problems with this today, and then you'll pick back up with the next video for the next step. Okay? Let me know if you have any questions.